Yeah, hi, my name is Johannes Tegnér. I've been working with development for quite a while, about a decade. And before that, I studied it. And my main area has been backend for many years. But the last few years, I moved more and more towards operations, DevOps, that kind of stuff. And I worked quite a lot with Kubernetes the last few years. I found Civo a few months ago, and I was quite intrigued by the managed K3s, something that I'm quite impressed with too. So yeah, I wanted to take them for a test drive, and seems to work very well. So today I wanted to talk about continuous deployment, something that I find very useful with Kubernetes. To do this, we need a cluster, which I think most of us know how to get it up and running. I have created a cluster before. So that I wouldn't have to mess that up in this talk. So yeah, I thought I would talk a short bit about how I think when I work with automation. Every command I write in my scripts, I write them as I was doing it manually while working. I test them in a container or directly in a Docker file to make use of the Docker cache. And when a command works, I move it over to the actual script, and I keep going like that until it's up and running. I don't optimize in the first pass. I just want to get something up and running, and then I make it better later on. Yeah, let's see. So we got quite a lot of different engines for continuous integration and deployment. I use Gitlab and their system for my files. They've been around a while and have developed quite a nice tool for continuous integration and deployment. There are many others. We just saw an example with GitHub. We got stuff like Jenkins and yeah, a lot of others. But if it's built into the Git provider, it's quite easy to get it to run right away. Yes. So to start off, when I deploy, I never want to deploy with a user that is root. So I always create a deployer service account. I put it in the namespace that it should be using instead of allowing it to use all the namespaces. And yeah, I could show the sorry. It's quite basic. It got access to the resource that it could need, but I don't allow it to do very much. I allow it to update and patch and also check deployments and pods and services and stuff like that. So I always manually deploy for the first time when I deploy, while I then let the deployer, the script, patch it later on. So as this project that I already set up to, which I'm showing here, we need to export the Kubernetes service count information and put it in a config file to be able to actually access the cluster. So I put together a small script. Exports it. No, sorry. Exported them and quickly create a config file. And here we go. So I bring this with me to and now I have added it to the repository so it can access the cluster API. So CI and CD is nothing without the scripts, of course. To get the most out of the pipelines, you will want to run all your tests before any deploys are made, and make sure everything works as it should. So I usually, before I deploy my first version, I always run the tests in the development branch and merge it into the master branch, which I use to deploy. This is a script for the Cube demo project. It's quite simple. All it does is it tests the code. In this case, it checks so the file exists, and then it only does this on the development branch, or on all branches except master. As if it's merged into master, it's already tested from the other branch. While the master branch will containerize the application. So when it runs, it tests on the development branch, and on the master branch, it creates a container. This needs to be done before actually deploying manually too, because if we haven't, there won't be an image to actually deploy as the application. Now let's see. So the deployment. It's a quite basic deployment file. It contains a deployment and a service. The service uses a node port because it's easy. I could have used an ingress like Andy did, but I thought better to keep it simple for now. It got 5 replicas, and it uses the rolling update strategy. I find this quite important because then I can choose how many versions, how many pods are running while it deploys. So right now we got it running, and this is the cluster, and this is the page. So so I thought we should try to do a deploy with a deploy script. So we can jump in here into the web IDE. And I created this a bit before, just to make sure we can change the index file to commit. In this case, I commit to the master branch. It should be protected and only accept pull requests. But in this case, I I'll do it this way. So now, now we can jump to the pipelines and check what happens. Let's start with containerization, which is done with Docker and a CLI plugin called BuildX to allow some extra syntax and to allow multi-platform support. So let's see what happens when we deploy. Now I use kubectl directly as a executable in the image that the runner uses, but you could basically use curl or whatever to patch the image. So now, as you might see, all the pods have been updated and the old ones removed. They were updated quite fast because they have no startup health checks, but yeah, it seems to work. So now we got a fully functional script, which every time we push to the master branch, it will deploy a new version without any downtime for the users to be annoyed. And I think that should be it.
Okay. Johannes, I had a question about BuildX.
Yes, of course.
She said, "I'm curious how." Oh,
sorry, your mic dropped.
And your thing's gone. I'll read it out for you. I'm curious how Docker BuildX's performance when this is run in production. Actually, I'm curious about the performance when this is run in production, considering how it's still on the edge branch, as far as they're aware.
Yeah. Well, I don't really use it in production. I use it to build the images. When the images are built, it can be deployed to any architecture that you build it for. In my case, I mainly use AMD 64 and ARM 64. And the steps when it built, it uses QEMU, which is single core and quite annoying to use. So I usually build it on the actual platform, all the binaries, and then import them into the container, into the image during the containerization script. So it works, but I wouldn't build CPU heavy images